All right, so we're going to look at the last little part of section 8.6. Our goal today is for you to be able to actually write out the objective function and the constraints and then finish up the question like we did yesterday, where you graph them, you check your vertices in the objective function, and you determine your max and mins. Okay? The trickiest part is to take this big word problem and break it down into the pieces. So my first suggestion is read through the whole thing once so you kind of have an idea of what you're looking at, and then go back and pick it apart. So it says bottled water and medical supplies are to be shipped to survivors of an earthquake by plane. Each container of bottled water will serve 10 people, and each medical kit will aid 6 people. Each plane can carry no more than 80,000 pounds. The bottled water weighs 20 pounds per container, and the medical kit weighs 10 pounds. Each plane can carry a total volume of supplies that does not exceed 6,000 cubic feet. Each bottled water is 1 cubic foot, and each medical kit also has a volume of 1 cubic foot. How many bottles of water and medical kits should be sent on each plane to help the most people? So we are trying to maximize what? What's the last sentence say? Most people helped. We're trying to maximize how many people we can help. What we're trying to figure out is how much water and how many medical kits should we send to do that. Does that make sense? Okay. So we want to maximize people. So our objective function is going to have something to do with the people that we can help. Okay? When we look at our objective function, that's basically trying to answer that question of what is the goal of the problem. Okay? The letter that you use here, I put P. You can use any letter you want. I try to make it stand for something in terms of the context of the question. So the number of people that we can help. In order to write this objective function, we have to know what our variables are. Okay? Most of the time we use X and Y. We could use a W for water and an M for medical kits if you want to do that, but you have to still state what you've used. Okay? So I'm going to say X equals the number of containers of water, and Y equals the number of medical kits. Okay? Now, we have to go back into that word problem and figure out if we're trying to maximize how many people we can help, how many people can we help with a bottle or container of water? How many people can we help with a medical kit? Okay? So go back in here. It says each container of bottled water will serve 10 people, and each medical kit will aid 6 people. So for every X, for every container of water I send, I can help how many people? 10. So I'm going to have 10 for every X. How many people can I help with a medical kit? Okay? I like to get the objective function written out first because then those numbers are out of the way. We never graph that objective function, right? We just set it aside until we come to the end where we plug our vertices into that. So now we have to go back to the word problem and find all the little constraints that we have. It helps to kind of think of the types of information that you're given. Our next line here says, each plane can carry no more than 80,000 pounds. Okay? We're given a weight restriction. So we have a constraint that deals with weight. The water, it says, weighs 20 pounds per container, and the medical kits are 10 pounds. So what kind of inequality can I write? So less than or equal to? It says no more than, but we could get to exactly 8,000 or 80,000. Yes? So less than or equal to 80,000. All right. Then it says each plane can carry a total volume of supplies that does not exceed 6,000 cubic feet. So there's a limited amount of space in the plane. Okay? All right, so for volume, it says each bottle of water is 1 cubic foot. Each medical kit is also 1 cubic foot. So 1x plus 1y, and my maximum I can reach is 6,000. Okay? There are two other constraints that we have to list. Anybody know what they are? X and Y can't go below 0. We can't send a negative number of bottles of water and a negative number of medical kits. We can send nothing. We're not going to help very many people that way, but that's the absolute lowest. So I would include in here that X and Y both have to be greater than or equal to 0. Even though they're implied, we have to state them. So we have a system of 4 constraints. The bottom 2 in purple there tell us we have to be where on our graph? In quadrant 1. All right, so we're going to focus on graphing the green and red inequalities and know that we have to stay in quadrant 1. Okay? All right, so let's start with green. If we make our table of values, if we put 0 in for x, what do we get for y? 80,000 divided by 10. 8,000. Okay? If we put a 0 in for y, what's 80,000 divided by 20? Okay? All right. For the red one, what are my intercepts? Both of them are 6,000? Okay, so looking at those numbers, our smallest is 4,000, our biggest is 8,000. Looking at my graph, we should figure out how we want to space this out. Okay? We mentioned it yesterday. You don't want to make your graph so small that you can't read it, but you do want to make sure it fits on your grid. Okay? So, what do you want to use for tick marks? If we go by 1,000, we're basically counting up a maximum of 8 marks. Could we go beyond that? Could we say 1,000 is every 2 tick marks? So we're going by 500s instead? That'll spread it out a little bit. Okay. So we said X was the water, right? And Y was medical kits. All right, so we're going by 500ths. Every 2 tick marks would be 1,000. All right. Bless you. So for the green one, we have 8,000 for our y coordinate, and we have 4,000 for our x coordinate. Okay? And for the red one, we are at 6,000 for each. All right, go ahead and get your lines drawn in. Are we looking at shading underneath the lines or away from the origin? Based on our inequalities. The origin works in these, right? So we are shading towards the origin, but we have to stay in quadrant 1. So our region that we're looking at would be this part. Okay. What's our next step? Find the vertices. All right. The objective function that we had was 10x plus 6y. All right, so vertices. Down here we've got the origin. Going upward, this one would be 0, 6,000. How about this one where they intersect? And remember we said yesterday that you should double check that point in both the green and red equations? Okay, so if we put 2,000 in here and 4,000, does it work? In both of them? Okay, so we've got the right point. Our last dot here, vertex, was 4,000, 0. All right, so then what do we do with those points? All right, let's plug them in. In the first one, we're putting in 0, 0. So we can help no people if we don't send anything. Second one, we're going to send no water, but we're going to send 6,000 medical kits. So how many people have we helped? Okay. Our third point, we're going to send 2,000 containers of water. We're going to send 4,000 medical kits. How many people can we help that way? 10 times 2,000 would be 20,000. 6 times 4,000 is 24,000, so 44,000. And our last option is to send 4,000 containers of water, but no medical kits. Maximum number of people we can help would be 40,000. Okay. Now remember, the goal of this question was we want to help the most people. So which option is our best one? $44,000 is the biggest one, yes? Now, yesterday when we didn't have a context to this, when you didn't know what X and Y stood for, we would just say my maximum is 44,000 at the point 2,000, 4,000. Okay? Now that we have a context to it, I want you to actually answer the question. So in this case, we would say we can help a maximum of 44,000 people by sending what? 2,000 containers of water and 4,000 medical kits. Questions about that? So, same basic process that you were doing yesterday, we just have to come up with those equations first. Okay? So, our next one, we are going to set the whole thing up, and then our last one, we'll just set up the inequalities in the objective function, but not graph it. Okay? It says a company makes bookshelves and desks. Let X be the number of bookshelves, and Y be the number of desks produced daily. All right, so X is bookshelves, Y is desks. It says the company makes $25 for every bookshelf and $55 for every desk. To maintain their high quality, the company cannot manufacture more than a total of 80 bookshelves and desks per day. The company must make between 30 and 80 bookshelves daily and at least 10 but not more than 30 desks. How many bookshelves and how many desks should be manufactured each day to maximize profits? And what is the maximum daily profit? Okay, so right here, they are telling you what your objective function should be about. We are trying to maximize profit. Okay, so let's go back in the word problem and figure out our equation for profit. How much are we told we make on every bookshelf? Okay, and then 55 for every desk. So my objective function would be 25x plus 55y. All right, now, our constraints are a little different in this one. It says to maintain their high quality, the company cannot manufacture more than a total of 80 bookshelves and desks combined per day. What does that mean? Total bookshelves and desks combined. X plus Y has to be less than or equal to 80, okay? All right. What are my intercepts for that? All right. The next statement says the company must make between 30 and 80 bookshelves daily. They are giving me a low end and they're giving me a high end. I have to be between 30 and 80. Okay? So if X has to be greater than or equal to 30 but less than or equal to 80, can we put that together as a compound one? You saw some of those the other day. 30 is less than or equal to X and X is less than or equal to 80. Okay with that? Okay. Then it says we need to make at least 10 but not more than 30 desks. So similar statement. Our lower end is 10, our upper end is 30, but this time we are talking about desks. So we're looking at Y. Do we need those implied constraints where we said X has to be greater than or equal to 0 and Y has to be greater than or equal to 0? They're still there, right? But we have a different cutoff, right? They're telling me I can't go below 30 for X and I can't go below 10 for Y. So do I have to worry about getting all the way down to 0? No. Those quadrant 1 constraints would get overridden by these. Does that make sense? Okay. Let's go ahead and figure out our tick marks. We don't really need to make a T-chart for the compound inequalities. We've got a low end and a high end. And when it's just a plain X or a plain Y in between, we're talking about vertical and horizontal lines, right? So we don't have to worry about the T-chart. The only T-chart we're looking at is the 80s. And we're dealing with 10s, 30s, 80s, 30s here. So highest number we would need to get to is an 80. What do you want to do for tick marks? Go by 5s? So every 2 tick marks would be 10? Okay. All right. So we'll start with the red one. We have 80 for both of them for our intercepts. So we'll go ahead and get that line drawn in. Are we shading above or below that? Below it, the origin works? Okay. So we're shading underneath that line. Now, for the green one, we want x to be bigger than or equal to 30, but smaller than or equal to 80. So we are looking at a vertical cutoff at 30 and another vertical cutoff at 80. We need to be in between those two lines. And then for the blue one, we're looking at horizontal lines at 10 and at 30. And we need to be in between those, correct? So if you picture your vertical and horizontal lines, they've kind of made a box. We have to be inside that rectangular box. And then we have to be underneath the red line. So our shaded area would be in here. Are we okay with that? All right, let's list our vertices. So this corner point, what are the coordinates of that one? 30, 10? Okay. Go ahead and go around the shape and write your vertices down. All right, agree, disagree? We okay with those points? All right, we're going to plug them into our objective function. All right, I'm going to go ahead and pause the recording. You guys go ahead and find those four numbers. All right, so for the point 3010, what did you get for RP? 1300? Okay, and for 3030? All right, somebody else, 5030? Okay. And the last one, 7010? Okay. So we want to maximize our profit, correct? Which one gives us the most? The 2900? So the 5030 option? Okay. So we would write down our maximum daily profit is $2,900 when we make what? 50 bookshelves and 30 desks. Okay? All right. So for the last question, it says, 2 manufacturing plants make the same kind of bicycle. The table gives the hours of general labor, machine time, and technical labor required to make one bicycle in each plant. For the 2 plants combined, the manufacturer can afford to use up to 4,000 hours of general labor, up to 1,500 hours of machine time, and up to 2,300 hours of technical labor per week. Plant A earns a profit of $60 per bicycle, and Plant B earns a profit of $50 per bicycle. How many bicycles per week should the manufacturer make in each plant to maximize profit? All right, so we want to maximize profit. Something in here told us about profit, correct? All right, looking back, we're looking at this sentence right here. Okay, that's going to go towards what? That's my objective function, all right? I'm going to use P for profit. What letters do we want to use for our 2 unknowns? We can use A and B. What does A stand for, though? It does make sense to use A and B. You can certainly use X and Y if you want. Either way, though, you should define it. So if we use A, what are we saying it's equal to? Look at your question again. How many bicycles should be made in each plant? That's your unknown, right? So A would stand for the number of bikes we make at plant A. Yes? And then B would be the number of bikes at plant B. Okay. So our objective function, P for profit equals 60A plus 50B. Yes? Okay. Now, notice in this one, instead of writing out all the different information in the word problem, they put it into a table. Table is sometimes nice to help you organize your constraint information. The pieces on the names for the rows over here, general labor, machine time, technical labor, those are the different types of constraints you have. Like in the airplane example we had with the water and the medical kits, our constraints were the weight and the volume. Okay? In this case, we're looking at general labor, machine time, and technical labor. Your unknowns should be the column headings. All right? So we used A and B for number of bikes at plant A, number of bikes at plant B. If you set it up in that order, where you have your different types of constraints labeled on the left, and up on the top you have your 2 unknowns, you can add a 3rd column over here for total. How much total time do we have for general labor? What did they tell us? We can use up to 4,000 hours of general labor. Yes? Up to means what? Less than or equal to? Okay. How much time did we have for machine time? Okay, 1,500. And we had up to 2,300 for technical labor. What you've created now, each of your rows is one of your constraints. It says that it's going to take 10 hours for every bike that I make in plant A, and I'm making A of them. Does that make sense? And it takes me 1 hour for each B that I make, each bike I make in plant B. So my first constraint is 10A plus 1B has to be less than or equal to 4,000. Okay, so each row is going to give you one of your inequalities. So what's the second one I'm going to write? 1A plus 3B has to be less than or equal to 1,500. And the last one? Okay. Are there any implied constraints? Can I make negative bikes? No. So I have to add in those other two. A has to be greater than or equal to 0. B has to be greater than or equal to 0. So I technically have 5 constraints that I have to think about. Questions on how we set that up? All right. So you are going to do just 3 of these problems, 17, 19, and 23. I believe it's on page 856. If the setting up is the more difficult part for you, I would set up all 3 here. Get your objective function and your constraints written out. Then you can do the graphing part and plugging your vertices in at home.